Hey, I'm glad to be with you tonight and to share a little bit about ecological restoration. I'm going to address four basic questions. Can we restore complex ecosystems? If so, how do we do it? And then what are the general procedures that we use for restoring ecosystems? And finally, what is it that is restored? You might think that we put it back the way it was. We go to try to put it back to the point that it was at the time of the founding of our country. You can't do that. And I'll tell you why later. So you got to stay. Okay, the complex ecosystem that I'm going to be talking about is the longleaf pine wiregrass sandhill ecosystem. As you know, it's a fire type, and the thing that burns primarily is wiregrass, Aristida stricta. And if you burn it every year, you get a lot of very interesting undergrowth in the ground cover, as you can see here in the foreground. And if you don't burn it every year, it begins to look like what's in the background across the road. That site had not been burned for about 25 years. If you go over there, it's kind of interesting. You get these nice big patches of cladonia, but these are temporary. They will soon be shaded out by more and more trees that come in there in the absence of fire. So if we go back across the road again and get into the annually burned or frequently burned area, you get a lot of different species. I'll just run through a few slides here without comment so that you can see some of the species that are there. One time I was running up towards Thomasville on Thomasville Road and got into a longleaf pine wiregrass sandhill area and kicked around for the day and was able to make a list of all the species that were out there on a late October day. And I came up with a list of 89 species. So we're dealing with a lot of different species in these longleaf pine wiregrass sandhills. If I'd gone out there at a couple of different seasons of the year, besides just one day, I would have probably added another couple of dozen or more species to this list. There's a lot of species out there that you have to deal with in ecological restoration. So can a degraded longleaf pine wiregrass sandhill be restored? And the Nature Conservancy has given us a good lesson about this at their bluff site over on the Apalachicola River south of Victoria Park. I think most of you have been over there and seen that area. You know that it was longleaf pine wiregrass at one time. All the vegetation was stripped and the area was planted to sand pine. The sand pines were harvested. The timber company did not make much money, so they sold the land to the Nature Conservancy, and the Nature Conservancy has been working for years to restore these lands. And their initial work over there, they were able to do it. They got two species in, the most important ones, longleaf pine and wiregrass. But they didn't get the other 87 species, or how many ever species are out there, in there at all. What they did was to grow wiregrass plugs in a nursery and then plant them in these furrows. And it was just straight wiregrass. That's all that came up, except where they planted longleaf pine. These are a couple of co-eds from a northern university who came down here on a spring break, and instead of going to the beach, they went to the TNC site and planted longleaf pine. That's a great way to spend your spring break, I'd say. Nowadays, though, the Nature Conservancy is doing a lot better job of getting other species in their restoration sites. They're using a seed stripper called a flail vac, which has this rotary brush right here, which brushes the seeds off of wiregrass and any other plants that are out there that are in fruit at the time. And then they take all that material that's brushed off, put it into sacks temporarily to store it. And then they put it into a fleet of what they call grasslanders and go out and plant all those seeds. And those grasslanders are pretty interesting contraptions. They have big hopper over here that the seeds fall through, and they fall between these disc harrows that make furrows in the ground and these rubber tires. And so the seeds are in the furrows and the rubber tires close up the furrows so that all that good seed does not become lunch for a flock of doves. And that's how they do it. Now, can a landowner restore longleaf pine wiregrass also? Well, Bill, raise your hand. Bill Stinson over here has done it on his property, and here's a picture of him. He's the one in the purple shirt, not these green things. Those are the trees. Anyhow, he was able to do a little bit of restoration on his own land in Gaston County and got a pretty good crop of wiregrass and other species coming in and longleaf pines. And he was actually able to get a good burn this spring, as you can see here on the left. And then on the upper right, you can see the one area that he burned that had just been burned. And below that, 2 weeks later, you can see all the sprouts of wiregrass coming up after that fire. That was about 2 weeks, wasn't it, Bill? So we've answered the first question. Can we indeed restore complex ecosystems? Yes, on both a large scale and a small scale. So let's go on to the next question, which is, what are the procedures for ecological restoration? This is for any kind of restoration project. First is to ensure protection of the site. And the second one is to describe the degraded site before you do any work at all. And you'd write that up as a baseline ecological inventory. And at the same time, you also describe the ideal that you want. What do you want that site to look like after you restore it? And for this, you develop a reference model. Then you have to get support of other people, stakeholder support. And once you get their support, then you can develop a restoration strategy. What's the general way you're going to go about restoring in that particular site? And then you have to do logistical planning to see whether or not you have the wherewithal to do that kind of restoration strategy. If so, then finally you can start writing up instructions for practitioners to go out there to the degraded site and start doing restoration. And then once those instructions are written down, you can send your people out there and start restoring. So that's an awful lot of things you have to do before you actually go out and start restoring. If you skip one or more of these steps, you're going to have a crummy restoration. I guarantee it. There are a lot of crummy restorations that have been done in Florida over the years because all these steps were not taken. So this is an important slide. I think you really have to look at this carefully if you're going to do ecological restoration. And then there's one more thing that you got to do when you get your restoration done, and that's celebrate. Now, I want to go through each one of these 9 steps a little more carefully. Ensure protection. You don't want to go out there and spend a lot of time and effort and money doing restoration and then have your site turn into a parking lot or a gated residential community. So if the site is owned by, let's say, the Nature Conservancy, or it's on public land that's preserved, you can pretty well guarantee that your site is going to be preserved in perpetuity or close to it, as long as they don't put a pickleball court on the state land. This is a 17-year-old restoration site that I did in Central Florida on phosphate mine land that was restored physically. And this boomerang shaped area here that you see, that's 17 years of restoration. When I started doing the work on this restoration a year or two later, the mining company started mining this area right here. And they made a big mine pit. And so this is supposed to be a forested wetland restoration. All the water drained out into the mine pit. And I had to ensure that I was going to have a good restoration. So I had to run into the office and get hold of the mine manager and have a long talk with him. And he finally decided that he was going to go ahead and fill in these new mine pits that he had made with mine tailings and save the restoration site. So that's another example of ensuring that your site is going to be in there for a long time and it's going to work. Okay, the second thing on that list was baseline ecological inventory, in which we figure out what the causes of impact were in the first place. Why was the site degraded? What physical damage was done to the site by degradation? And then how was the biodiversity altered by that degradation? And that can all be figured out in just a day or 2 or 3 or so of field work. You don't need to have a big academic study on this. And you can write it up as a short report. And this particular slide, by the way, I was explaining to several graduate students there how you do baseline ecological inventories in a degraded forest, which was habitat for giant pandas on the Tibetan Plateau in China. And also, when you do your baseline inventories, take lots of photographs. This photograph is of a site that we were restoring in southern Mississippi at the TNC's Old Fort Bayou restoration site. And you can see there's a lot of trees in there. Those are slash pines, and a lot of tall shrubbery. A lot of that's large gallberry and tai and things like that. And we had to get rid of all that to restore this particular site, because here's the reference site a mile away in the Mississippi Sandhill Crane National Wildlife Refuge. It's a beautiful wet prairie, about 250 species of herbs making up that particular site there. And that's what we're trying to get that reference site back, or that baseline site back to this particular situation. So this was our reference model. It was a very easy reference model to come up with, because all you had to do was to go out there for a day or two with a clipboard and a pad of paper and write down all the names of the species that you saw. However, doing a reference site can sometimes be difficult if you don't have a very nice model like this to work from. Here's a remnant, or here's a reference site that was worked on on a small island on the east coast of Australia, which had been really degraded badly. Almost the entire island had been, and Australian restorationists, who are very good restorationists, by the way, had a hard time figuring out what the reference site ought to be, and develop a reference model, because this was the only, what you see here in this slide was the only remnant of original vegetation that was left on that island. And it was already degraded partially as well. So they were able to figure out a few species from this particular site, but they had to find other reference information. And fortunately, they had a couple of different sources. One was a book done by an artist of a lot of the species of plants that were found on that island back in the 1800s, when the artist did this work. And so those species could be added to the reference model. And then on the right, there's a list that was done by a botanist also in the 1800s, who happened to come through and make a list of plants that he saw on this particular island. So all of that information contributes to the reference site. You use whatever you can find to come up with your reference model. And be glad for whatever you can find. The next thing on the list is to get the stakeholders on your side to do the restoration. This is a group of stakeholders meeting in Ecuador. The project site was a gold mine where there are large piles of mine tailings that were just sitting there waiting to be restored, with vegetation waiting to be restored on it. And in this particular conclave that we had here, there were officials from government who had to authorize any restoration project. They were part of the stakeholders. There were representatives of the Gold Miners Union there. They were industrial representatives representing who were stakeholders. And there were a couple of school teachers in there as well. So we worked a couple of days, and they thought it was a pretty good project, and they approved it, by the way. Those big mining projects are pretty difficult, though, because you're completely stripping the vegetation off of wide areas. And so there's no seed source that you can depend on for repopulating revegetating your mine. And you have to bring in seeds or plants from elsewhere. And what they did in Ecuador and elsewhere, this is done all over the world, was to put in a native nursery. And this is a native nursery in Ecuador in preparation for a mine site where there were many different species being, native species being grown out. It's quite an effort. It takes a lot of work, some money. And if you have to put in a native nursery like this, why, that's what you got to do. Okay, the fifth item on that list of 9 was to develop a restoration strategy. This is a marsh on a ranch in Central Florida. And a couple of decades before this photo was taken, the ranchers had dug a big ditch that's pretty obvious across this marsh and drained it. And then they ran cattle on it because there was a lot of really nutritious maiden cane grasses growing on it that were good for raising cattle. Now, assume that you are a restoration ecologist and it is your task to restore this marsh. What's going to be your strategy? Well, the first thing you do is get the cattle off of there. Next thing you do is fill in this ditch and try to get the hydrology right again. The third thing you do is wait during the next growing season to see if there is a seed bank or rhizome bank still extant in this marsh, and that's good, will allow the marsh to become repopulated again with pickerel weed and maiden cane and the other species that are typical of that marsh. If not, then you're going to have to find a donor site someplace, a marsh nearby, and borrow seeds and rhizomes and set up a native nursery nearby and grow them out and replant this site. So that's your strategy. That's what I mean by strategy, is the general way you're going to approach restoration. The sixth thing on the list is logistical planning, where you see if there's practitioner availability to do your restoration, to see if you can get funding for your restoration, see if you can get permits from the government, make sure you have equipment to do the restoration, know if you have planting stocks available from a native nursery, for instance, to do restoration, and that you have a good project director who can direct the practitioners who are working on site. In this particular photograph, this is in the estuary of the Pascagoula River in southeastern Mississippi. The site is a small property owned by the Audubon Society. The shoreline was once a really nice sawgrass marsh with other buttonbush and other things growing in it. And it got really beat up pretty badly and pretty badly degraded. And so they wanted to restore it. And they got hold of a friend of mine, Jim Kelly, who used to work for me and is now working for himself over there and out of Ocean Springs, Mississippi. And he was able to get practitioner availability, those 5 high school students who you see in the picture. And the funding was easy because the Audubon Society was able to do that. And they were able to get their permits quickly. And they did not need grasslanders and seed strippers and things like this. As far as equipment was concerned, all they needed was a few shovels. Also, you see them there in the picture. And the project director was Jim himself, who knew a lot about ecological restoration and was able to direct these practitioners. So that's your logistical planning on that particular project. Then you have to come up with implementation instructions. to tell the practitioners what to do. And the first instructions you make have to do with stopping the impact, stopping the degradation. And then you come up with tasks for site preparation, physical site preparation. Make sure the elevations are right, the hydrology is right, the soils are right, physical environment is right. And then you start working on the biology. You remove the invasive species and other unwanted species. And you encourage desirable species to proliferate, whether it's from a seed bank or a native nursery, however you get those native species, desirable species in. When you do these tasks, you have to consider seasonality too. This is the time of year that you plant trees. You don't want to plant trees in the middle of the summer because if there's a drought, they're going to dry out, and if it's too wet, they're going to drown, and you're going to lose a lot of your trees. So you got to consider seasonality when you're doing these, working out these implementation tasks. And finally, you have to consider contingencies, because no restoration project ever, anywhere in the world, has ever gone completely right. There's always something that goes wrong. You get your site preparation just perfect, and you have these beautiful plants that are growing in the native nursery, and you bring them in, you start planting them, and a hurricane comes, washes everything out. You got to start all over again. And so you better have some funds in your budget for contingencies like that. Now, if it's a simple project, all you need for your implementation instructions is a poster like you see here on the right. That's all the project director is going to need to instruct the practitioners as what needs to be done. On a really complex project, you might need engineering plans and blue line drawings and a lot of text to specify exactly what the practitioner should be doing on site. Depends on the project. And you use your ingenuity. On that project that I showed you earlier about the Old Fort Bayou project in southern Mississippi, we had to get rid of all of those slash pines. And the usual way of getting rid of slash pines is to go in there with feller bunchers and big trucks and get them out of there. But that equipment would have torn up the land, and we were depending upon seeds in the seed bank to repopulate the restoration site with the plants we wanted in there. So we couldn't really tear up the land. Instead, we got this fella and his two horses to come in there and pull the logs out. And that saved the land from being scarred up by heavy equipment. And then we just gave the logs to this fella, and he carted them off to the pulp mill and sold them. And he made a profit doing that, and it didn't cost us a cent. So use your ingenuity when you're doing ecological restoration implementation. Finally, we get down to the implementation itself. This is another project of the TNC, about 50 miles from the coast on the Pascagoula River in Mississippi. And the Nature Conservancy owned about 5,000 acres of bottomland forest that looks like just like what's out on the Ocklagney River or the Apalachicola River floodplain. And Hurricane Katrina came along and blew down an awful lot of trees. And they wanted those trees to regenerate as fast as possible, so they asked my company to go in there and help them out. So we went in there to plant trees. The trees that blew down, in fact, the trees that were abundant in that forest were mainly water oaks, laurel oaks, sweet gums, ironwood, a few species like that. But our reference model said that 200 years ago, that forest was, although it contained water oaks, laurel oak, sweet gum, and ironwood, was mainly cherry bark oak, swamp chestnut oak, overcup oak, green ash, and willow oak. And so what we did was to develop bare root seedlings of these species here that were there a couple of hundred years ago. And so when we did the restoration, we were not only able to get the forest to start recovering fast, but also get the species composition that was there a couple of hundred years ago. Why did this forest contain today mostly water oak, laurel oak, sweet gum, and ironwood? It's because when the colonists first came into Mississippi, they would go into these forests and they'd take out some of the best trees. And then they depend upon natural regeneration for those trees to be replaced. And the natural regeneration was done by those species that produce a lot of seeds every year. Those were the water oak, the laurel oak, the sweet gum, and the ironwood. And so after several different forestry operations in there over the past couple of hundred years, you've got a complete shift from what was in there before to those particular trees. So that was a good reason to do ecological restoration at that particular site. Okay, that's the implementation that took place at that particular site. Now, we finally come to celebration. Why do we do a celebration? We get the stakeholders out there on site and show them our restoration after it's completed and say, hey, guys and gals, we actually did it like we said we were going to do it. And look how beautiful it is. And here's the baseline photographs that we took at the start of the project. And you see how cruddy it looked then and how beautiful it looks now. We really did it. And so we not only get the stakeholders out there, we get the politicians out there, including the regulatory community. And we'll say, hey, government, look at the great job we've done. Here's a microphone. You want to speak about it? And we get the politicians out there to give little 5-minute speeches because politicians love to talk. And what can they say? They can say, oh yeah, you did a great job. Okay. We also get the directors of NGOs and agency heads out there. And those are the people who are going to fund your next restoration project. And they are listening to the stakeholders and the politicians, and they realize that, hey, this is a good thing to fund, put our money behind, do more restoration. And so what we're doing here is setting up our next restoration project. We're making sure that the stakeholders are behind us, the politicians are behind us, and the funding sources are behind us. And we also get the news media out there with some camcorders and stuff so we get a little bit of TV coverage as well. And we've already invited food caterers out there so we have some food for people to eat, and that's going to make sure that lots of stakeholders come and lots of politicians come and so on. A couple of kegs of beer as well, and some musicians wandering around, and make it a big party so that we can set up for our next project. We're restoring our culture, essentially. Okay, that takes care of the third question that I wanted to address in this particular talk. The fourth one is, what is restored in ecological restoration? I told you that you can't restore it back to the way it was because biology is continually moving forward. So to really answer this question, first of all, let me give you what I think is a really good, terse definition of ecological restoration. Ecological restoration is a process of assisting recovery of biodiversity and natural functions in a degraded ecosystem so that they reestablish continuity with their interrupted ecological trajectories. How's that one? Let me read that again. Ecological restoration is the process of assisting recovery of biodiversity and natural functions in degraded ecosystems so that they reestablish continuity with their interrupted ecological trajectories. We got 4 terms there that need defining: assisting recovery, biodiversity, natural functions, and ecological trajectories. So let's look at those. Ecological or assisting recovery means that we only do what nature can't do. This is not an engineering project, not a forestry project, not an agricultural project where we completely manipulate the system. We only do what is needed to assist nature to put the ecosystem back again on its trajectory. The slide that you see here is a former longleaf pine wiregrass sandhill with a forestry project on it. You can see the row planted longleaf pines and the agricultural weeds that are growing there. No wiregrass, no none of the 89 species that you expect to find out there, under natural conditions. Biodiversity, the aspects that are most important, I think, to ecological restoration are: number 1, species composition. You want to get all those species back. You don't necessarily have to pave the entire restoration site with every last species, but at least get a few plants of every species back so that they can spread on their own. And you have to pay attention to the life forms of those species. What's a life form? Well, one example is a tree. Another one is a grass. Another one is a forb. Another one is a shrub. Another one is a nitrogen-fixing legume. There's lots of different life forms, and you want to make sure that all those are back. And of course, they will be back if you're able to get all the species back that's in your reference model, because those life forms together form the ecosystem structure. What you see out there, the physiognomy of the ecosystem is its structure, and it depends upon those life forms, and they provide the habitats for all the animals out there, and provide the basis for ecosystem functioning. Okay, well, what about those functions? Those natural functions include things like growth and reproduction of plants. You want your plants to grow, you want them to produce seeds and reproduce. And then you have trophic functions like photosynthesis for the plants, herbivory and predation amongst the animals, decomposition, which is, of course, taken care of by fungi and bacteria and vultures, earthworms, and all sorts of other creatures out there. And then you want you want the soil to be constantly improved by such things as augmentation of organic matter in the soil or better aeration of the soil. And then you want specialized functions like pollination and seed dispersal taking place. There are other functions as well, but these are some of the most important ones. Now, the thing to realize here is that all of these functions start on their own. Mother Nature takes care of it if we get the biodiversity right. If you go out there on your restoration site and some of these functions are not starting on their own, then probably your biodiversity, something's wrong with the biodiversity, either species composition and or structure. And you better make some adjustments on site as part of your restoration program. Now we get to the biggie. An ecological trajectory is the passage of an ecosystem through time. Those of you with gray hair, there's a lot of you, have been going out to your favorite natural area for many years, year after year after year. And each time you go out, you probably have noticed that there's at least a slight change. A big tree fell down. A couple of years later, you come back and there are saplings of trees growing where that big tree fell down. And they're not necessarily the same species of tree. It's a change. And changes like that are happening all the time. And they're happening more rapidly now with climate change. And so we realize that life is really a movie. It's not a snapshot. And we can graph this out, if you'll pardon me. Put states of biodiversity on the vertical axis and time on the horizontal axis. And now your ecological trajectory is this straight arrow that goes diagonally across. And if you're out there at any given time, you can look at your site, like this fellow's doing over here with his binoculars, and you see a snapshot. But if you're out there several years, you get one snapshot, another snapshot, another snapshot, and so on. They're all a bit different because this ecosystem is changing through time. And so this ecosystem is really a movie and not a snapshot. And we have to take this into consideration in ecological restoration. But okay, what's the restoration angle? Here we have our ecological trajectory, and it is interrupted by degradation. And so the continuity of this ecosystem is interrupted. And we may have to do ecological restoration to reconnect, reestablish continuity. And when the ecosystem is restored, in other words, we get the biodiversity right and we get the natural functions working again, then we consider it restored and we have continuity reestablished. And anything we do to that ecosystem later on is not restoration, it's ecosystem management. A lot of people think that ecosystem restoration goes on for 200 years to be able to make a 200-year-old forest. It doesn't. That's ecosystem management. Okay, how do we know when our project site is restored? We monitor. You can go out there and make measurements of plant growth and that sort of thing. But my gosh, ecosystems are very complex. And there's an awful lot of things you can measure, and you don't have enough time to measure everything, and you don't have enough funds to measure everything. You just measure a few selected parameters. And the rest of the time, you've got to go around and use your observation and make notes. And you come up with all these observations of most of the ecological attributes that are out there. Okay, so you can't come up with one single number that says, okay, you went from 9 to 10, therefore it's restored. You can't do that. There's just too many attributes out there. So what do? Here's what I suggest. You use a recovery wheel. Of ecological attributes. And on this wheel, You have one section here, which is absence of threats. In other words, that there's no more impacts that would degrade the site. And there's some other attributes that have to do with the physical condition. Is the physical condition, as the physical site, okay, good hydrology and all that. And then there's some more that have to do with species composition. We've already talked about that. And also the structure. And also ecosystem function. Have all these attributes. And then we're down here to the external exchanges. And those exchanges are things like, well, migratory birds don't hang around in your ecosystem all the time. They go in and out by the season. And a lot of other animals go in and out. And so you have these external exchanges of organisms. If your ecosystem is at the bottom of a hill, you have water flowing down that hill into your ecosystem that supports it. And so that's an external exchange of a physical aspect of the environment, water. And you absolutely need that for your biodiversity. So that's what I mean by external exchanges. Now, there are also 5 concentric circles here, 1, 2, 3, 4, 5. 1 is your baseline condition. 5 is your fully restored condition. 2, 3, and 4 are the stages in an ecological restoration project. Now you've got all sorts of little can't call them squares, can you? Polygons out here. What do you do with them? Well, let me give you an example. You fill them in when you have finally taken care of a particular aspect. So in this particular partial restoration project, we've got pretty good physical conditions already established. So those are all filled in with green. But ecosystem function isn't quite there yet at all. We have a lot more to go to get ecological function back. And so just by looking at this recovery wheel, you can get at a glance a good idea of where your restoration site is, where you're going to have to put in more work, where you might have to go to a funding source and show your funder, hey, give me some more money to finish off this particular part of the project. And they can see exactly why it is that you're asking for that money from this recovery wheel. So this becomes a very handy way of assessing where you're at a restoration project. And finally, when you get everything done right, you've got the entire area green. And that's what this particular project that my company did in southern Mississippi, what they came up with. This is a fully restored ecological restoration site. Applause. Thank you. You know, and so I do want to show one more slide here about the restorative continuum. Everything we've been talking about is trying to put nature back the way it was. Ecological restoration. And you can only do that in natural areas. You can't do it in an urban area. You can't do it in a suburban area or a rural area where there's a lot of agriculture and other activity going on. But you can do partial restoration in these other areas. For instance, you can do native plant landscaping in an urban environment, even if it's on the top of a building. That's an improvement, and it's something to be applauded. If you're out in the suburban or exurban areas, you can do remediation, which is the recovery of selected functions. You might use native plants to stop erosion or to slow down flooding. So you're recovering some functions there. Or further out into the country, you might be doing rehabilitation, which is defined as partial ecological restoration. You're essentially getting half of your recovery wheel covered in green. And that's certainly a lot better than none of it at all. So any of you who want to be doing ecological restoration of some sort on your own property, realize that you can be somewhere on this restorative continuum and will be doing good things for the environment and for the native plants. So that ends the formal part of my talk, but I do want to give a few slides having to do with the field trip coming up on Saturday. This Saturday's trip, we're going to be discussing the strategy for ecological restoration, trying to restore the 18th century upland vegetation in the Tallahassee Red Hills. That's not the only thing we're going to be doing on that field trip, but nonetheless, that's going to be a theme. And just to give you a little bit of background on that, a couple more slides. There was a pine oak hickory woodland in the Tallahassee Red Hills. We have very good documentation of this from historical records. And there's hardly any of this vegetation type left. This particular site is on a remote aspect at Tall Timbers. And it doesn't look anything, it doesn't have the same biodiversity at all of what we see out there today in most of the Red Hills. The trees that are out there are shortleaf pine, Spanish oak, post oak, black oak, white oak, mockernut hickory, pignut hickory, sorghum, dogwood. Those are some of the more common trees. There's a lot of undergrowth that species that are different from what we ordinarily find in the Red Hills today and are found only in the remnants of this particular vegetation type. We will find a few of those remnants on our field trip on Saturday. Some of these pine oak hickory sites are burned regularly and they look like this. Some are not burned and they get brushy in a hurry. This is an 8-year rough, and that'll develop into a forest, and that's okay. It's still part of the upland pine oak forest. It's got the same species composition, just lacks the ground cover. Land use history of the area. We started out with pine oak hickory to begin with. And then from 1824 to 1875, there was massive clearing of the land and cultivation during the plantation era. After about 1875, a lot of that plantation land was left fallow and it grew up in agricultural weeds and broom sedge, and trees quickly moved in. And it was the bottomland trees that reproduced quickly that became abundant on the upland in the absence of fire, because fire was no longer burning here. And these included loblolly pine, sweet gum, water oak, live oak, black cherry. Those are all lowland species, which are probably more abundant on the upland today because of this land use history. And then if you let this area develop, it'll develop into a forest that looks like this. It's pretty nice, but it has absolutely, or very few of the species that are in the pine oak hickory original forest. Or if you burn that, it looks like this. Again, you don't have the same species, you don't have the pine oak hickory species there. They're the old field species. So if we want to restore a site to pine oak hickory woodland or forest, we're going to have to remove all those post-agricultural colonizers like loblolly pines and water oaks and sweet gums. And we're going to have to plant in the native upland trees and herbs. And if we want it to be a woodland, we're going to have to burn it occasionally. If we don't burn it occasionally, it'll turn into a forest. That's okay. You can do either one. So that's essentially what we're going to be talking about on the field trip on Saturday. I think that's all, folks. And I'll do my best to field a question or two if you want.
I feel like I just got like the cliff notes of ecological restoration and young folks here might not realize that ecological restoration hasn't always been a field. And so, Andy started the Society for Ecological Restoration, and how many years ago?
With other people. Yeah. Oh, let's see. We started the society in 1989.
So thank you. That was awesome. Yeah. One question. What is the fire referring to?
If you want the woodland, it might be every 3 or 5 or 8 years, something like that. Not as much as longleaf pine wiregrass. By the way, you will get longleaf pine wiregrass up on tops of these hills in sandy soils. So there is some of that ecosystem there too, but most of the area was the pine oak hickory. Yep.
Disturbance. Oh, sorry. Do we have species lists?
Species
from-
list? Yeah,
Yeah.
Gene mentioned a paper that I published on this that has species lists in it. And then Kevin Robertson at Tall Timbers has done a lot more work on it. He has longer species lists. So those species lists are available. If anybody wants a copy of my paper, I've got it on a flash drive. We could transfer it tonight to if you have a laptop or something like that with you.
Nice.
Yeah.
You showed at the mine sites and described them as being stripped down initially. And
Yeah.
I assume that stripped of all the soil.
Yeah.
Some of your other sites, it seemed like they'd been disturbed in other ways, not necessarily stripped of the soil.
Yes.
How much more of a challenge is it when you have zero of the original soil?
Lots. You really have to be careful. Those phosphate mine lands, which is where I got my start in this field. You start out with sandy soils, and you end up with sandy clay soils because the overburden they put back in is all mixed up, and that screws up not only the soils but also the hydrology. And then they had reclaimed some hillsides next to my wetlands and put bahia grass in there. And every time it rained, you have bahia grass seeds coming down into my wetland side. And I had to keep going out there with herbicides to get rid of the bahia grass. It's a mess. We're able to do it, but it's sort of like trying to pull a railroad car with your teeth.
Thank you. It was very informative. I am wondering, how do you know what to restore to? How do you make that decision of what the reference model is going to be?
I'm glad you asked that question because I got one more slide that shows that. I'm interested in something that not too many restorationists have really addressed at all. And that's restoration ethics. And so I want to choose local donor sites for getting my propagules and seeds, if at all possible, because we don't want to spread narrowly endemic species beyond their known ranges of geographic distribution. You know, when Alan gave his talk a couple of months ago here, well, he talked about a lot of very narrow endemic species. We want to make sure that when we restore, that if one of those narrow endemic species was a couple of miles away from our restoration site, we don't want to use that species in the restoration site. However, if we have widespread species like longleaf pine, then we can go out beyond the range and plant those if we need to. For instance, if you know that you've got climate change and it's getting warmer and drier, and the rainfall patterns are different, we might want to be actually introducing different species, widespread species, into a restoration site that did not occur there originally, because we're trying to restore a moving target, that ecosystem trajectory that I talked about. We want to restore so that try to meet that trajectory. Now that takes some real thinking to do it right, but nonetheless, it's a possibility.
Andy, I'm sorry, I forgot, I've read your paper years ago, and what was the basis? What is your argument for why the Red Hills was shortleaf rather than longleaf pine? Was it based
Well,
on early survey records
yeah.
and data?
Um,
But those data were in the
there-
early 1800s, right?
the
After the Indian,
in 1778, they put in the road from Pensacola to St. Augustine, and they came right through tall timbers. And there's a topographic engineer involved in that, whose name was Joseph Purcell. And Purcell not only did the topography, but he also described the land and land use, and to some extent the vegetation, in a rather broad area. And he found a lot of this pine oak hickory, particularly the open phase, up along the state line in Tall Timbers area. And it was a bit denser down here towards Tallahassee, but it was still there. And he was also noting where the Indian old fields were, agricultural fields. And then several other people like Vignoles and John Lee Williams were also mentioning this in their 1800s publications. And I looked at the original surveyor notes from 1824 and made a map of Leon County based on their descriptions of vegetation at every section corner. And there was a lot of pine oak hickory in there. However, they did not mention what kind of pine it was. But it was pretty obvious from the other species that it was this
Well,
mixed
just
pine hardwood mess.
curious
And
about
then
what-
one more, Bruce.
Yeah, go ahead.
There was a professor in one of the schools up in Alabama who was hired to come in to do the write-up for the 10th census of the United States for cotton lands in 1884, fellow by the name of Gene Smith. And he mentioned that there was over 1,200 square miles of pine oak hickory forest along that just south of the state line from Gaston County over to Madison County. So there's a lot of information that shows that it was there.
Well, the only reason I ask is because all those data are, 1800s sort of data. And by that time, the Amerindians had been around here in this Leon County area, especially for centuries before that. I
Yeah.
wondered how much influence the Indians might have had to changing what might have been original longleaf mosaic to a
Oh,
shortleaf pine one.
well, surely pine had to get here somehow. It had to,
Oh, yeah.
but
It's the big conundrum for where the hell
Yeah.
shortleaf pine come from.
well, of course, that's throughout a lot of the southeastern states and up particularly the Ozark area, Boston Mountain area, and in that area.
Well, I know of Kevin's work, that northeast, west corner of Tall Timbers
Yeah,
was apparently a pretty
Yeah.
good original shortleaf pine. And
the Indians were not doing much agriculture right up along the state line. They were doing most of their agriculture further south, and Purcell's map from 1778 shows that pretty definitively. And it's in that area, closer to the city of Tallahassee, where we get the kind of pine oak hickory forest that has little pine, and it's mostly forest. It's not open. And I think what probably happened there was the DeSoto expedition came in and essentially vacated all the Indians that were here, all the Appalachian Indians. And therefore there was nobody doing any burning anymore. And so that forest developed in this area here. And John Lee Williams, in his book in 1837, described the forest as pretty dense right here near the Cody Scarp, where the Cody Scarp starts. So the area up near the state line was still I think the area that was not managed by Indians much at all. They were managing the land further south in the county.
like,
So that's what it looks like to me.
well, thank you very much.
Yeah. Yes, there are soils differences. You get the longleaf pine up on the tops where there tends to be a sandy caps of soil. Now, a lot of that sandy cap has since eroded because of plantation agriculture. And so what you have on top of the hills now is the original clay subsoil. But nonetheless, there are still areas around the county where you do get the longleaf pine, wiregrass, sandhill type vegetation, where where it's not been disturbed and where you haven't had the erosion of the sands. Not much of it, but some.
Anyone else? All right, yeah. All right, we'll see you on Saturday. If we don't see you then, hope everyone has a wonderful holiday season, and we'll see you January 7th on Tuesday, not on Thursday. So thanks, everybody.